Hello, this is Mr. Collier, and today we're looking at inequalities. Inequalities use these symbols, less than or equal to, so this sign means it could also be equal, greater than, or equal to. So let's look at some examples. D is less than 5, so D is less than 5, we write it like that. That means D could be anything less than 5, like 4, 3, 2, negative 5, 0, even fractions like 4.9 are less than 5. So let's look at this one here. 4 is less than y. You write like that. Negative 20 is greater than or equal to x. So it could be, or another way to write this is x is less than or equal to negative 2. Okay, so that makes it a little bit easier to understand sometimes. So this means numbers like negative 2 or anything less than negative 2, like negative 3, negative 4, negative 4.5, things like that. Z is greater than or equal to 0. We'll write it like this. Okay? So basically Z is not a negative number, so it could be 0, 1.2, anything that's bigger than or equal to 0. Okay, next we're going to solve a few inequalities, or inequations as they're sometimes called, or inequalities, and show their solutions on number lines. So we'll do that in a second. So they work very similarly to equations. You can subtract 4 from both sides of this inequality. We have a is greater than 2. Okay, so that means a is not just one number, it could be any number that's greater than 2. So we can represent that with a number line. Okay, I'm going to stick 2 in the middle, and then a number that's less than 2, and a number that's greater than 2. And so a number that's greater than 2, well, 3 is greater than 2, 4 is greater than 2, 3.5, 2.5. Now it can't be equal to 2. It can be greater than 2, but not equal to 2. So I'm going to put a hollow dot here to represent the fact that a cannot be equal to 2. But a could be 2.1, which is right about here, and 2.2 and 2.3, and so forth. It could be any decimal between 2 and 3, or even beyond that. So if you start filling in all the dots, all the values that a can be, you basically get a complete line that goes on forever in this direction. So this is why the graph looks like this. Okay, a hollow dot show that 2 is not included, but 2 can be anything bigger than 2. Okay, in this next example, we can divide by 3, and we get b is less than or equal to negative 3. So I can draw a number line with negative 3 in the middle. A number less than negative 3 is negative 4, and then bigger is negative 2. Okay, less than or equal to negative 3. So I'm going to draw that in red. So it's less than or equal to negative 3. Numbers include negative 4 is less than negative 3, negative 5, negative 3.5, but also could be equal to negative 3. So we use a solid dot this time and not a hollow dot. We'll use a solid dot, and then we'll draw our arrow this way. This represents b is less than or equal to negative 3. In the next example, we can multiply both sides of this equation by 3, and we get c is less than 6. So I'm going to draw the number line over here, 6 in the middle, and then 1 less is 5, 1 bigger is 7. I should have probably spaced that a bit better. Less than 6 does not include 6, and less than is this way, so this is how we draw the graph. Okay, in our last example, we can solve this by adding 4 to both sides of the inequality. We have negative 6 is greater than or equal to 3x. Okay, I'm going to finish that over here. Negative 6 is greater than or equal to 3x. We can divide by 3, and we got negative 2 is greater than or equal to x, which, like I said before, you can rearrange this, put the x on this side, but this is like x is less than negative 2, so I have to flip this around like this. So this is x is less than or equal to negative 2. Okay, so I can graph that. Here's negative 2, and then we have negative 3 and negative 1. So less than or equal to negative 2. Let's get red here. Okay, it could be equal to negative 2, so we do a solid dot. Less than is this way. So this is what the graph looks like. Okay, let's do one more example. In this one here, we're going to add 1 to both sides. We have 5x is greater than 3. And if I divide by 5, I get x is greater than 3/5. So now how to do this in the number line? Well, 3/5 can be in the middle, and the easiest thing to do is just go one numerator ahead, so we can say this is 4/5, and one behind is 2/5. So I can graph that now. This is greater than, so you don't use a solid dot, you use a hollow dot, and it's going to be greater than, so it's this way.